Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is the 91st lecture of physics, and today's lecture we are going to start a new chapter with the name of Converging Lens. Uh, Dear learners, optics is a very important field of physics, and this is in the continuation of previous few topics. In the previous unit, we learned that light is refracted when passing from one medium into another. In this unit, we will learn about the effect of a lens has on light. We will also learn about the feature of lenses as used in various image forming devices. For example, camera, the overhead projector, and the magnifying glass. In this regard, we are turning our focus to the first topic, and that is general information about the converging lenses. Uh, the first subtopic is types of lenses. Now, to understand this unit perfectly, then you must have to understand the different types of lenses. Lenses are commonly made of glass or clear plastic. They are widely used in spectacles, cameras, projectors, telescopes, and many other optical instruments. Our human eyes have two special crystalline lenses which enable us to form images. There are two main types of the lenses, and the first figure, which is this one, is showing in the form of two columns. On the left side, we are having the converging lenses. Uh, the second one is called divergent lenses. Now, in conversion lenses, there are three different types. The first one, you can see here that it is given as the bioconvex lens. It is also known as double convex lens because two uh, lenses are combined together. For example, this one, and there is another lens is combined together, and they are making from it a lens like this. So there are two plano-convex lenses are combined together, and we are getting biconvex lens. You have to remember this. Now the second type is this one, and that is called plano-convex lens. The first one is also known as double convex lens, and that is a plano-convex lens. Why? Because one side of it is plane, and the second side is convex. So in this regard, they are known as plano-convex lens. The third type of lens is concavo-convex. One is the concave, and that is a shape of concave, a cave like shape. So one, this is convex, and this is concave. So that is why it is called convexo concave, yeah, concavo convex lens. These are the three types of converging lens, and their center is further, uh, their center is fatter. For example, if you are making it like this, so their center you can see as fatter. So whenever their center is fatter, then you must have to understand that this type of lens is called convex lens. Now turn our focus to the concave or diverging lenses. In this regard, there are three types of lens, in which the first one is bioconcave lens. Now, there is one concave lens in this form, and there is another concave lens in this form. When they are combined together, they are making, and you have to remember that there are two plano-concave lenses are combined together in this type of lens. One more thing you have to remember, that the center of it is thinner. You can see that their center in this location is thinner as compared to this one. Their center is fatter. So this is called biconcave lens. Now the second type of lens in this regard is plano-concave lens, just like this one. One side is plane and the second side is cave. So that is why it is known as plano-concave lens. Now this third type is convexo-concave. One side is convex and the second side is concave, so that is why it is known as uh, convexo concave lens. So generally there are six types of lenses which can be categorized into two different section. One is called converging lenses and the second one is called diverging lenses. Lenses are commonly made of glass or clear plastic. Remember this. They are widely used in spectacles, cameras, projector, telescope, and many other special type of instrument. Now, video cameras, uh, the television screen, older one, they are all the inventions of optics. So keep this in mind. Uh, this unit is particularly dealing with the converging lens, no concave lens. Just I give you the information that there is a concave lens as well, but that is not the topic of our interest. So we will focus on the convex lens, which is also known as converging lens. Dear learners, how rays are behaving inside the converging and diverging lens. Let us study about this. We are talking about this particular figure. The converging type of lens converges. What does it mean? It means brings together what? Rays of what? Of light. Is shown in this figure, the first one at the left. And you can see that if parallel beam of rays are passing from the convex lens, then they will be converging at a single point, that is called the focus point. We will discuss that in today's lecture, that what is the focus point. But here you have to remember that if parallel rays are passing from the convex lens, they will be converged to the single spot, that is called focus. On the other hand, the diverging type of lens diverges. What does it mean? Spreads out. Rays of light is shown in this figure. So when rays are passing, I should say parallel rays are passing, then it will spread, not converge. It will spread in different direction. And if we extend each ray on the left side, then there will be a focus point here. Dear learners, you might have heard that there are weaknesses of eyesights. Many people are having the weakness of long sighted. They cannot see things clearly which are far away from them. And there are other categories of people who are not being able to see the things which are very close to them. So for one type of eyesight weakness, diverging lens, and the other type is known as converging lens are used. Sometimes if both the defects are present in a patient eye, then both converging and diverging lenses are incorporated in one type of spectacles. And you might have seen that at the bottom there is a curved semicircle type of lens at the bottom. They are used for close-sighted people, and the other is for long-sighted people. So you saw that these are the two types of lenses, converging and diverging, and what they are actually doing. One is converging parallel beam of light to a single spot, and the second one is diverging it from a single spot and spreading it in different direction. Now next topic is here is the thin converging lens. So let us start thin converging lens. Now thin converging lens is shown in the figure. Let us discuss that. These two figures show the action of a thin converging lens on a parallel beam of light. What actually they are doing? A thin lens can be defined as a lens whose thickness is small compared with the focal length. So if its thickness is small, because you can see here that the focal length is larger than this region, which is the thickness of the lens. So if the focal length is larger than the length of the lens, the thickness of the lens, then it is known as thin converging lens. A thin lens can be defined as, very technically, a lens whose thickness is smaller compared with the focal length of the lens. So you saw this, both of them. It is not mandatory that the parallel beam of light should come well on 90 degree to this lens. It might be like this. As you can see, both are thin converging lens. They are thin converging lenses because their focal length is larger than the thickness of the lens, and in this particular case this is the uh, P that we will discuss in a moment, but this is the F focal length. P is principal axis. So we will see what is principal axis in the uh, next topic, which is known as main features of thin converging lens. So let us discuss to understand the concept of lenses clearly. There are many terminologies associated with the concept. You must have to be a master and crystal clear in your mind on those terminologies. I am discussing that topic under the name main features of thin converging lens. So number one is you must have to understand the optical center. If there is a lens, so this will be the optical center. Which one? This will be the optical center. When you are laying a lens on the table top and whatever point is touching, there will be only one point because the surface is a curvy one. So only one point will touch the tabletop or the floor wherever you are putting it. So that will be known as the optical center. Let us discuss for a symmetrical biconvex lens. This is the point midway between the lens surface on its principal axis. We will discuss that. What is principal axis? You have seen that this is the principal. If a line is passing through this optical center without any deviation, then that is called principal axis as it is written here. And in this case, this is passing the optical center without any deviation. So that is also P, and that is called principal axis. Proper definition we will do in a moment, and let's do it. The second one is the principal axis. I told you what is the principal axis, but let us define it formally. This is the line passing symmetrically through the optical center of the lens. If this line is passing through the optical center, it will not be showing any deviation. As you can see here as well, that this dash line is passing from the optical center without any deviation, and you can also see that this line is also passing from the optical center without any deviation. So these are called principal focus, principal axis, and it is always denoted by the P. The next term is the principal focus, the place where, the point where all the rays are converging. This will be the rays, and it will be going to only one point. This is called principal focus, and it will be on the same distance on both sides of the lenses. So that is why we are calling it principal focus. Now the focal length is the distance between optical center and the focus point, and this is known as F. The optical center, which is this one, and the focus point, which is this one, the distance between these two points are known as the focal length. Now the next very important term is the focal plane. This is the plane which passes through F and P. That is passing F and P. This is F and this is P. So if this is a line which is passing these two points F and P, then this is called what? This is known as focal plane. The focal plane is perpendicular to the principal axis, as you can see that it is perpendicular. Now, super class important topic is the ray diagram. Keeping in mind those points, we have to draw a diagram. Many questions are given in the exam. Many questions are given in the exam to complete the ray diagram. So the basic concept is finished. Now we are turning our focus to the mainstream topic. So let us understand that how we will create a ray diagram. Super class easy. We have to follow 3 steps, and understanding those 3 steps will make you enable to create a ray diagram. First, you have to keep in mind that if a line is passing, if a ray is passing from the optical center, it will go straight without any deviation, as you can see in this step number 1. This line is passing through the optical center, and that line is passing without any deviation. This dash line is known as principal axis. So principal axis is also the ray which is passing the optical center and without any deviation. So you have to keep this thing in mind. The second step, you have to understand that the parallel line after passing the lens, which is this one, will go directly to the focus point. Remember, this is the second step, the most important one. If a parallel ray is passing through this lens, so it will diverge to the focus point. The third one is also important. If a line is passing from the focus point, so after passing that line from the lens, it will become parallel to the principal axis. In this case, if a line is passing parallel to the center, and then it will be diverged to the focus point. But let us do it in this way as well. If I am going from this, it will go out from this lens. So incoming or outgoing rays must be considered. These are the three steps you have to follow to make a ray diagram. Let us clear this concept with the help of work example. Let us understand the work example. The work example is saying an object 2 centimeter high. Now this is an object which is 2 centimeter high. You have this graph paper, and in this graph paper there are small squares. So we made a scale here. Horizontal scale is 1 square. Small square represent 1 centimeter. And one vertical square is also representing 1 centimeter. So they given us the object 2 centimeter high. You can see that there are two small squares. So that is why we are saying that O represent object, I represent the image. So this is the I. It will represent I and I dash, that is represent image. So when you are creating the ray, you have to keep in mind those three steps. The question is saying that is placed 7.5 centimeter from the converging lens. So you can see that this object is 1, 2, 3, 4, 5, 6, 7 and 7.5 squares, means 7.5 centimeters. From where? From a converging lens. In this case, converging lens is shown by a double headed arrow, and that is the lens which is denoted here. So that is the lens. You don't have to make in this particular case that lens of greater thickness, to be very much precise. Okay, further the question is saying the focal length of the lens is 5 centimeters. So it will be 1, 2, 3, 4 and 5 on both sides. This will be on 5 centimeters. Find by scale drawing the position of the image. Describe the characteristic of the image. Very important characteristic. So first, let me erase these things from everything from this diagram. So we will see a clear-cut diagram in this case. Okay, first of all, as you learn in the previous chapter, that the foot of the image will be drawn on both sides, it will be here at double of the focus 2f. When this is not a plane mirror that you will say that on both sides the distance will be equal. No, after passing it will be magnified. Magnification is our topic in tomorrow's lecture. Stay tuned for that. Very important, how to magnify it. And the second one is this one. So one, because this point is passing directly from the optical center, so it will not be deviated. The second point at the top, which is head, it will go parallel, and after passing this lens, it will be focused on this f, and you have to increase that line in this case. Now the third thing, you have to carry a line from the head directly from the optical center, and you know that it will be undeviated. So wherever these 2 points lines are meeting, you have to draw a line from here till here, and that will be the image formation of this object. So in this way you can create the image. Now you can see that the image distance is how many centimeter? 1 square represent 1 centimeter. So let us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So that is why I have written here image distance from the lens is 15 centimeter. Now they ask about the different characteristics, so let us discuss the characteristics as well. The first one is the image is the image is inverted upside down. You can see. So very interesting scenario here. That is erect image object here, but the lens is making it inverted. So what is interesting and which is amusing me is that whenever the object of the image of an object is portrayed on our retina, it is upside down. Yes, everything on your eyes is upside down. There are other lens and other criteria which is making it erect. So by default all the images made by the retina is inverted. So the first characteristic of this is inverted. The second characteristic is real. What does it mean? If you are putting a screen here, you will see a clear crystal image. If at the point of image which is formed, if you are putting a screen there, you will see a clear cut image, so it is a real image. The image formed by the television screen, if you are putting there, removing that television screen, and you are putting a projector screen there, Panaflex, white, so you will not be able to see any type of image. That is a virtual image. So in television screen, LEDs, LCDs, etc., they are making an image which is what? Which is the virtual image. So in this case, this is a real image. And it is magnified. If you can see that there are 2 centimeter, but here if you are seeing that whether it is virtual or magnified or not. So you can see that there are four, 1, 2, 3, 4 squares are there, and here they were 2. So it is magnified image. You will see a large image of that object you are observing through convex lens. And this is the one thing more, then we are finishing it, that this is a focal length, and that is 1, 2, 3, 4, 5, another focus point which is called 2f. 1, 2, 3, 4. So that will be here, and the next one will also be like this. So one is 1f, then there is a 2f, and there is a 3f, and it will be on both the sides. So that's it for today. Tomorrow magnification, linear magnification is there. So that is also very, very important topic. Don't miss it. Stick to me for that. Thank you very much for your time. Allah Hafiz.